Go.
So I'm going to be doing the 2015 AP Calculus AB free response question number 5. And then, so the first thing I'm going to do is read the problem. And the problem says, the figure above shows the graph of f prime, the derivative of a twice differentiable function of f. On the interval of -3 to 4, the graph of f has horizontal tangents at x equals -1, x equals 1, and x equals 3. The areas of the regions bounded by the x-axis in the graph of f prime on the intervals -2 to 1 and 1 to 4 are 9 and 12 respectively. So with that, once we look over at the graph, we can notice a few things about it. So right here, it told us that the area is going to be 9 and 12 here, right? And then let's read the first question that they give us. Find all x coordinates at which f has a relative maximum. Give a reason for your answer. So we can see that a relative max of f occurs when f prime changes sign from positive to negative as x increases. And the only place where that happens is at -2, because it goes from a negative to a positive. From a positive to a negative on this part of the graph. So then we could write a relative max occurs when f prime changes sign from positive to negative at x equals -2. And that right there would be your answer for part A. It's actually really just looking at the graphs, which helps you with these type of problems. Alright, so part B is asking on what intervals contained in -3 to x to -3x to 4 is the graph of f both concave down and decreasing. Give a reason for your answer. So in order to find this, we need f prime to be greater than 0 in order to satisfy the decreasing of f requirement. We also need f double prime to be greater than 0 to satisfy the concave down requirement on the graph of f and f double prime. F prime in order for f double prime to correspond to a negative slope. These two conditions are met for -2x to 1, -1, and 1x to 3. And as you can see here on the graph, between -2 and 1 and 1 and 3 is where you meet where those are met. And then for part C, it says, the question asks, find the x coordinates of all points of inflection for the graph of f. Given that, for the graph of f, give a reason for your answers. And we can say that a point of inflection occurs when f double prime changes sign from negative to positive. And the only places where that happens are -1 and 3, which they change here they become from negative to a positive slope, and then also here at 1, which is a positive slope down to a negative slope. So we could write the x coordinates points of inflection, occur at x equals -1, 1, and 3. That would be your answer for this one. And finally, our last question says, given that f of 1 equals 3, write an expression for f of x that involves an integral. Find f of 4 and f of -2. So this one involves integrals, and what we first have to do is come up with an equation, which would be we have to write the equation of f of x, not f prime of x. So we have to write f of x equals, and then since it says that it's 3, we have to add the 3 in there, plus the integral from 1, because that's what they're giving us, that f of x's, to x whatever we have to plug in for these two. And it's f prime of x dx. So then once we plug in, it's f of 4 equals 3 from 1 to 4. F prime of x dx will equal 3 plus negative 12, because that's what the area here is. And since it's underneath the x-axis, it's a negative, which would make it equal to negative 9. That would be the answer for the first one. So, and then once we go on to the next part, we have to plug in for the second part, which would be f of negative 2, which would equal negative 3 plus 1 to negative 2 f prime of x dx. And we have to flip the 1 to the top, because since your second one is a negative, it always has to be at the bottom. So that means that we have to move a negative side to the front, turning the 3 negative, and the bottom, it moves a negative number to the bottom. And once we plug it in, it would equal negative 3 plus negative 9, which will make it equal to negative 12. So your answer should be negative 9 and negative 12. And that's how you get the answer. Thank you.